If area of triangle with vertices 2, 5, 7k and 3, 1 is 10, then we have to find the value of k. And we know that to find out the area of triangle, first of all, we have to find out d. So in first row, let's place 7k. So it will be 7k1. Then second row, let's place 251. And finally 311. Now let's find out determinant by expanding with respect to first row. So their sign will be plus, minus, and plus, and their respective elements are 7, k, and 1. Now let's find out minor of 7 by ignoring its row and its column. So let's cross multiply. 1 5s are 5 minus 1 1s are 1. Now let's find out minor of k by ignoring first row and second column. So we have to multiply 1 with 2 will give us 2 minus 3 into 1 will give us 3. And finally, for last element, we have to ignore first row and last column. 1 2s are 2 minus 3 5s are 15. So here we'll get 5 minus 1, or we can say 4. 4 into 7 will be 28 minus 3 minus 1 will be minus 1. So here we'll get plus k minus 13. So your D will be k plus 15. Now we know that area of triangle is given by 1 by 2 mod D. We already have area of triangle as 10. So we'll get 1 by 2 mod k plus 15. Or we can say k plus 15 is equal to 20, or k plus 15 is equal to minus 20. So here we'll get k is equal to 5 or k is equal to minus 35, which is given in option B. Ta-da! If maximum and minimum value of this determinant is P and Q respectively, then we have to find 2P plus 3Q. So to get maximum value, first of all, we have to expand the determinant. First of all, let's simplify this determinant by taking operation. R1 gives R1 plus R3. So in this operation, second and third row will be as it is. Now to find first row, we have to multiply third row with 1 and add into the first row. So 1 1s are 1, then cos theta 1s are plus cos theta, and 1 1s are again 1. So 1 plus 1 will become 2. Cos theta will cancel out, will get 0, and 1 will cancel out, will get 0 again. So we are ready to expand with respect to first row. Your first element is 2 and rest of the elements are 0. So we don't have to worry about them. Just find out minor of 2 by ignoring its row and its column. So we have to multiply 1 with 1 minus cos theta with minus cos theta will give us plus cos square theta. So we get our value of determinant, but we have to find minimum and maximum value. And we know that the maximum and minimum value of cos square theta 0 and 1. So let's obtain your determinant. And for that, we have to add 1. So here we'll get 0 plus 1, or we can say 1, then 1 plus cos square theta, and here we'll get 1 plus 1, or we can say 2. Now to obtain determinant, we have to multiply all the terms by 2. So we'll get 2 times 1 plus cos square theta and 4. So we get maximum and minimum value of D, which is 2 and 4. Here your P is maximum and Q is minimum. So your P will be 4 and Q will be 2. So we are ready to find out 2p plus 3q. Substitute the values, you will get 2 times 4 and 3 times 2, or we can say 14, which is given in option C. Ta-da! Here we have one matrix equation and we have to find the value of x. So we have multiplication of three matrix A, B, and C. So first of all, let's try to multiply A with B. The order of A is 1 cross 3 and order of B is 3 cross 3 and order of C is 3 cross 1. So if we try to multiply A and B, then your resultant matrix will be in terms of 1 cross 3. That means we will have one row and three columns. So let's try to get your first element, which is in first row and first column. So we have to multiply first row with first column. So here we'll get 2 ones are 2 plus 3 twos are 6 plus 4 threes are 12. Now the next element is in second column. So multiply 2 with x will give us 2x plus 3 into 4 will give us 12 plus 4 into 2 will give us 8. And finally, your last element will be 2 threes are 6 plus 3 fives are 15 plus 4x are 4x, and your rest of the terms will be remain as it is. Now let's simplify. 2 plus 6 plus 12 will be 20. Then here 12 plus 8 plus 2x will become 2x plus 20. And your last element will be 4x plus 21. So we are ready to multiply AB with C. Your resultant matrix will be order of 1 cross 1. That means we will have only one row and one column. So let's obtain by multiplying your first row and first column. 20 multiplied with x will give us 20x plus 2x plus 20 multiplied with 2 will give us 4x plus 40 plus 4x plus 20 multiplied with 0 will give us 0 is equal to 0 matrix. So if we compare elements, we will get 20x plus 4x, or we can say 24x plus 40 is equal to 0, which will give us x is equal to minus 40 by 24, or we can say minus 5 by 3, which is given in option C. Ta-da! In this question, it is given that x raised to 4 plus y raised to 4 and z raised to 4 is equal to 0. All the terms have even powers. So we can say all the terms will be positive, and it is only possible if x is equal to y is equal to z is equal to 0. So we can say it is given. Then we have to find the value of determinant, which is formed by xyz. Now if you substitute the value of xyz, your determinant will become 1 0 0 0 1 0 and 0 0 1, which is determinant of identity matrix. So its answer will be 1, which is given in option C. Ta-da! In this question, we have matrix A, 1 1 0 1, and we have to find matrix B, which satisfies this equation. AB is equal to BA. So let's assume matrix B, which should be order of 2 cross 2, is A, B, C, D. Let's try to get your left hand side, which is A into B. Your matrix A is given as 1 1 and 0 1. And your matrix B, which we assume as A, B, and C, D. Now, both matrices are order of 2 cross 2. So we can say your resultant matrix will also have order of 2 cross 2. That means we will have 2 rows and 2 columns. So let's try to get your first element, which is in first row and first column, by multiplying first row and first column. 1 will multiply with A will give us A, plus 1 multiply with C will give us C. Now let's try to get your second element. 1 multiply with B will give us B, plus 1 multiply with D will give us D. Now for element of second row, the first element is in first column. So multiply 0 with A will give us 0, plus 1 with C will give us C. And your last element is in second column. So multiply 0 with B will give us 0, plus 1 with D will give us D. So your left hand side will be A plus C, B plus D, C and D. Similarly, let's try to get your right hand side, which is B into A. So resultant matrix is order of 2 cross 2. So let's try to get first element, which is in first row and first column. So 1 multiply with A will give us A, plus B zeros are 0. Then the second element can be obtained by A ones are A, plus B ones are B. Then element of second row, which is in first column, will be obtained by C ones are C, plus B zeros are 0. And the last element will be C ones are C, plus D ones are D. So we get our right hand side and left hand side, and it is given that AB is equal to BA. So we can compare your left hand side with your right hand side. Now let's compare your first element. We will get A plus C is equal to A. Your AA will cancel out and you will get C is equal to 0. Then compare your second element. We will get B plus D is equal to A plus B. So your BB will cancel out and we will get A is equal to D. Then if we compare third element, we will get C is equal to C, which we already find as 0. And from last element, we will get C plus D equal to D, which will give us C equal to 0, which we already find out. So to satisfy this equation, we will get two conditions, that A must be equal to D and C must be equal to 0. So we can say your matrix B will be converted into A, B, your C must be 0 and D must be A. So any matrix which is in this form is your final answer, which is given in only option B. Ta-da! In this question, we have A is equal to one matrix which have all the elements as 3, and we have to find A raised to 3. Actually, for this special kind of a matrix, we have A raised to n is equal to 3 raised to n plus 1 into A. In this case, your A is 3. So your answer will be 3 raised to 3 plus 1, or we can say 4. So your answer will be 81 times A, which is given in option B. Ta-da! Here we have to find the value of this determinant. So sine square theta will multiply with sine square theta will give us sine raised to 4 theta, minus cos square theta multiply with cos square theta will give us plus cos raised to 4 theta. The answer is not given in these terms. So to simplify, let's add and remove 2 sine square theta, cos square theta, and your cos raised to 4 theta will be as it is. So here we'll get sine square theta plus cos square theta the whole square, minus, to simplify this last term, let's multiply and divide by 2. So we will get 4 sine square theta cos square theta whole divided by 2. Now we know that sine square theta plus cos square theta is nothing but 1. And in second term, we have the whole square of 2 sine theta cos theta divided by 2 will be as it is. So your final answer will be 1 minus sine 2 theta the whole square divided by 2. But the answer is also not in this term. So let's convert this sine square theta in terms of 1 minus cos square 2 theta. So here, so let's take LCM. We will get 2 minus 1 plus cos square 2 theta whole divided by 2. So 2 minus 1 will be 1 plus cos square 2 theta will be as it is whole divided by 2 is your final answer, which is given in option 3. Ta-da! If determinant is equal to 2016k, then we have to find the value of k. And for that, we have to find the value of determinant. Now, we can take 1 factorial common from the first row and 2 factorial common from the second row. So, after taking 2 factorial common, your second row will be 1, 3, and 4 into 3, or we can say 12. Your first row will be as it is, and 3 factorial will be rewritten as 6. Similarly, from third row, we can take 3 factorial common. So after taking 3 factorial common, third row will be 1, 4, and 5 into 4, or we can say 20. So your 2 factorial will be 2 and 3 factorial will be 6. And let's expand your determinant with respect to first row. So first of all, let's write down the elements and sign of the elements of first row. Now let's try to get minor of it. The minor of first element will be obtained by ignoring first row and first column. So we have to cross multiply 20 with 3 will give us 60 minus 4 12s are 48. Then the minor of second element will be obtained by 21s are 20 minus 1 12s are 12. And the minor of last element will be obtained by 4 1s are 4 minus 1 3s are 3. So here we'll get 2 into 6 will give us 12. Then 1 into 16 minus 48 will be 12. Then minus 2, 20 minus 12 will be minus 16. And 6 into 4 minus 3 will be plus 6. So finally, your D will be 24. And it is given that D is equal to 2016k. So we can say your k must be 24 divided by 2016. So we will get k is equal to 1 by 84 as your answer. Ta-da! In this question, we have one matrix AR, which is R minus 1, R minus 1, R, where R is 1, 2, 3 up to 100. And it is given that summation of determinant of A from R equal to 1 to 100 is equal to under root of 10 raised to k. Then we have to find the value of k. So first of all, let's find out determinant of A. And for that, we have to cross multiply. R multiply with R will give us R square minus R minus 1 into R minus 1 will give us R minus 1 the whole square, which can be expanded as R square minus 2R minus 1. So here we'll get 2R minus 1 as determinant of A. So let's move to the next step, in which we have to take summation of determinant of A. So 2 will be as it is summation of R minus summation of 1. Now we know that summation of R is nothing but n into n plus 1 by 2 minus summation of 1 will be n. But it is given that your summation is from R equal to 1 to n equal to 100. So substitute the value of n, we will get 100 into 100 plus 1 minus 100, which will give us 10,000. Now, it is given that summation of determinant of A is equal to under root of 10 raised to k. We already find out summation of determinant of A, which is 10,000. And right hand side can be rewrite as 10 raised to k by 2. We know that 10,000 is nothing but 10 raised to 4. So if we compare the power of 10 on both sides, we will get 4 is equal to k by 2. Or we can say your k must be 8, which is given in option 4. Ta-da! Here, A is a square matrix such that A square is equal to I. Therefore, if we multiply A on both sides, we will get A cube is equal to A. Now let's expand A minus I the whole cube, which is A cube minus 3A square plus 3A minus I cube. Similarly, let's expand A plus I the whole cube, which will be A cube plus 3A square plus 3A plus I cube minus 7A will be as it is. Now here minus 3A square plus 3A square and minus A plus I will be cancelled out. So we will get A cube plus A cube, or we can say 2 times A cube, and 3A plus 3A will be 6A, and minus 7A will be as it is. Now we know that your A cube is nothing but A. So this 2A cube will become 2A. Then 6A and minus 7A will become minus A. So your final answer will be A, which is given in option C. Ta-da! In this question, we have function of t is equal to one determinant, and we have to find limit t tends to 0 for f of t upon t square. So first of all, let's try to get the value of determinant. Now, we can expand our determinant directly, but before that, let's try to get maximum zeros. So let's take R2 gives R2 minus 2R3. So in this operation, your first row and third row will be as it is. Now let's obtain your second row by multiplying minus 2 with third row and add into the first row. So 10t minus 2 will be minus 2 10t, then minus 2t and minus 2t. So in first element, 2 10t will be cancelled out, we'll get 0. Then t minus 2t will be minus t, and in last row 2t will be cancelled out, we'll get 0. So we can expand with respect to second row. So let's place their sign and their elements 0 minus t and 0. We don't have to worry about these two elements because they are 0. Just find out minor of minus t by ignoring its row and its column. So we have to multiply t with cos t will give us t cos t minus 10t with 0 will give us 10t. So we get your f of t. So we are ready to find limit t tends to 0 f of t upon t square. We already find out the value of f of t, which is minus t into t cos t minus 10t whole divided by t square. 1 power of t will be cancelled out, and if we simplify our function, it will be minus cos t plus 10t by 2. So if we apply the limit, we will get minus cos 0 plus 10t by t will be 1. And we know that cos 0 is 1. So your final answer will be 0, which is given in option D. Ta-da!